Here we are on the scene, guys. Got the I-manifold set up. Getting the Zebrastat out, about to plug it in so I can control the unit because no one's home yet. A little bit early out to the job. This is the one where I built the monster hood. Now that right there is a hood. It's like a spaceship. So we're going to hook up everything, see how it goes, and see what she looks like. We have the Zebrastat hooked up. I'm going to turn on the green for the fan. I got it hooked directly to the green wire coming in. I have the yellow for the contactor hooked directly to the contactor. There's our power, 24 volts. We can get our W signal and O signal. W being heat strips, O being the reversing valve over here. Let's go ahead and turn on the fan. It will have a little delay on it, we should hear it. Alright, you can hear the fan right there running. So what we'll do now is we'll kick in the heat. And that will be cool one, because this is a heat pump. We're using the Y signal to the contactor. So we'll go ahead and let everything get started and take a look at it in a few minutes. Alright guys, now that we've been running for a few minutes, our pressures are sort of stabilized there. We're going to flip the switch and have the reversing valve kick in. Let's see if we can make it make some noise. Let's see what happens. Well, she went in just fine. A little loud. Not too bad at all. So I wonder what the noise is here. We'll let her switch back. We'll run her in cooling for a minute. We'll switch her back to heating while she's running and see if we have a little bit of a groan then. Alright guys, we've been running and cooling here for a few minutes. We're going to turn that reversing valve off over here, which is hooked up to the defrost board to the Zebrastat. Let's shut it off and see if we can make some more ugly, horrible noises. Same noise you would expect from a scroll. I don't know if it startled the homeowner. There must be something more to this because I can't believe that that's it. Kind of strange for sure. I'll do some more looking around and see if we can come up with something. Guys, I'm going to turn on the heat strips now. And basically I just plug the heat 1 wire right here on the Zebrastat over to the W signal coming out the defrost board. And what will happen is when the unit goes into defrost, it'll send a signal for the heat strips to come on, so it won't give that cold shot of air inside the house because the system will be running in air conditioning. So we're just going to run it right now and see what happens. Hopefully nothing except for a little bit of amperage. We'll go over to the electrical panel and see if we get the proper amperage, which should be in the 34 amps range, we'll say. We'll walk over here. Got the panel opened up. Easy access. See what we get. We do have a sequencer, so it'll be on delay for a second. And then we should have 30, 34 amps, something like that. Looks about like half of it. Half the amperage we really need right there, so there is something wrong with that heat kit. We'll have to go take a look at it. We are looking inside of the heat kit. We have our two incoming lines of power, our black and red. What I have is I have one of my plunger leads on either end of the string of the heat kit. So inside of these walls you see a metal wire wound around, which electricity runs through. There's resistance. It heats up. Air blows across it. That's where you get your heat from heat strips. So I have my leads on either end of this bank of heat strips. We have one right here and then one right next to it. So let's go to the first one. We look down there, we see it's 13.7 ohms, which means there is continuity through there. So let's go to the next set. We have open line. That means we take this kit out, we should see some sort of damage to that line of the heat strips. So we're going to take it out and take a look at it. We are looking down at the heat strips now, and you can see for sure that line of heat strips is busted right here. There's a noise complaint. I still don't see how this makes a noise complaint. I can see this sort of rubbing up against these other lines of heat strips. It may be causing some electrical noise, but I don't see how they would even hear that. So I'm not quite sure it is what they're hearing. You can see that these are covered in some kind of moldy substance right there, which would be nice if we had some sort of UV light on the system. But it's been off for a while. I mean, it hasn't worked all season, this season at least, because all that stuff would have been burnt off of there. So I'll disconnect these, disconnect this whole ring so it won't interface with the primary ring that's still working. And we'll go ahead and put them back in there and fire it back up and see how she works on one set of heat strips with that thing removed. I removed that first bank of heat strips, just cut them out of the way. There they are down there on the ground. One thing is, when they short together, it's going to draw an erratic amount of amperage through the circuit, because sometimes they're shorting, they flex and move when they get heated up, so you can have some strange things happen. So I have one bank. I'll remove the wiring to that bank as well, so there's no power to it. So I'm going to go ahead and put it back in, and we'll fire things back up once I remove that wiring. We have all the wires hooked back up. Our main power, 240 volts, our ground. We have a low voltage plug here. Actually, it's not all low voltage, just one high voltage wire for the fan. For if the heat strips are energized, it'll send power to the fan if there's not already power to the fan from the G signal. So we've taken all the wiring off this one bank of heat strips. Of course, we've saved our wires. I think all of us who work in heat pump markets have seen heat strips that have wires pulled off of them because they failed over the years. So on this one, we'll probably get a brand new heater because we're not restringing a heater. I've only restrung a heater one time, and that's because they no longer made that particular heater. So as long as they still make this one what they do, it'll be HKR 08, we'll be good to go. So I'm going to put everything back together, we'll fire it back up, and put it to the mill again. We are back at the panel. I'm looking at 15 amps or so on both legs of the power. Before I had an erratic amount of amperage. I had 15 on one side, 25 on the other. So I think we're dealing with 3 or 4 kW of heat. There's probably like a row of 5 kW, then a row of 3 for the 8 kW heater. So that's probably what we're looking at. We probably just have access now to the lower kW range since the higher was damaged. We're going to turn everything back on as far as heat, run it for a few more minutes, see how we do. Alright guys, I'm in here going to short out the defrost sensor. So we think we're very cold. And then I'm going to pull that test pin off. I'll pull that pin on this 90 minutes right now off and short it out with a thermostat screwdriver. And try to yank it out so it goes into defrost. And I can yank it out in time to keep it in defrost for a minute. Alright, there we are in defrost. We switched over just fine. Let's keep it in there for 10 or 12 more seconds. We're going to pull out this pin to make the unit know that the defrost should be over. As you see, if you leave the test pin in place, it will go quickly in and out of defrost, but if you yank it out at the right time, it'll basically let you run a whole cycle. Because the test pin rapidly speeds up the timer, so it will rapidly speed up defrost for you too. Alright. And we did just fine. So I mean, it's loud, but I mean it's gonna be loud, you know what I'm saying? Sorry. No problems here. We'll confirm she's running at heat properly again, and then I'm pretty much done, because that's all I can check here as far as noises. I think we're good to go. Hopefully the electrical played a role in the noise she heard, or else she just mistaked that growl of the scroll for something wrong. Guys, I have my meter leads on either side of the defrost thermostat that hooks up to the outdoor coil to sense temperature. And right now we are 24 volts because the switch is open, so it shows the voltage across the switch. Now as I go around the corner, I hooked up another defrost thermostat. You see the lead right here on the outdoor coil, and the tone is it is now closed. So the one I hooked on is closed, but this one here is still open. So we're going to pull the fan lead off, get the temperature to drop rapidly, see if this switch will in fact close. After the fan lead was pulled off, right here, from the defrost board, right down here, the pressure dropped and temperature dropped on the coil, and we actually did get that switch to close as well. So just a little bit less sensitive location. This switch closed first, but they still both work. So probably not an issue with the switches. You could change the location to make it a little bit more sensitive as far as the amount of defrost you're going to get, but the point is it will still defrost, and you won't have a complete ice blockage or anything like that. So we're good to go here. Everything looks pretty good except for the heater, so we'll inform the customer, and hopefully that is the end of the nasty noises, or at least a awareness of what they are in the case of defrost.